last thing we're going to see for this week is on to chapter 3. We're going to start talking about truth tables by looking at them for our simpler compound statements as well as negations. Where to start, let's take a shot at a basic example of the type of thing we're thinking. This one is going to be a bit less meaningful than the others for the sake of clarity and to remind us this is a math class after all. Here, let's say the statement is 7 greater than 6. Excuse me, that's P, Q, statement 5 less than 6. Look at these two statements. Hopefully, you can tell that P is true and Q is true. Meanwhile, if we were to look at their negations, if we were to take the opposite of this, opposite of 7 is greater than 6, is 7 is less than or equal to 6. Hopefully we can tell is false. And similarly, if we negated Q, we would get 5 is greater than or equal to 6, which is also false. In general, when we talk about these statements, something that's very important that we build to, something that we're really working with here, is the idea of whether or not they are true or false. Existence isn't necessarily defined, that is, the existence of a statement isn't defined whether it's true or false, but that is the main thing we want to be able to talk about, whether or not these are true statements. And then we got the single statement and the single action on the varieties. So let's think about what we might do with compound. Let's say we instead looked at and or P or Q. Let's say we looked at the basic disjunction. Well, we could write this as 7 is greater than 6, or 5 is less than 6. When it comes to disjunctions, we're saying either of these, either works. In this case, both are true, so that means that this whole thing is true. Meanwhile, if we look at the conjunction and Q, we get a similar statement. 7 is greater than 6 and 5 less than 6. Since both are true statements, this whole thing is, again, true. But if we then start to look at mixing and matching, some of this stuff with the negations in the original statements, like say if we were to look at not P and Q, you would be saying, okay, 7 is less than or equal to 6 and 5 is less than or equal to 6. True, because the first one. But if we said not P or Q, the second is true, the whole thing would be true. And that's a lot to take in, that's a lot to think about. There are a lot of different moving pieces we can throw together here. So, big thing to get is that representing these options can take a while, can be hard. It'd be hard to think of all these things, at the very least keep them straight in your head. So, we use what are called truth tables to organize them. Where what a truth table is a basically diagrammatic representation of the options for a given statement or modified statement or conjunction, disjunction, what have you, some arrangement of statements into a compound statement so you can see when things are true or false. So for example, if you want to look at negation, what we can do is make a table where in our first column, we're going to put in all of our statements. Let's just say with some statement P, our first column is just going to be that statement P. And then in our second column, we are going to draw the negation, not P. Where in our column of statements, what we're going to do is just fill out the possibilities, either true or false. Here, P can be true, or P could be false. Here, P is true, for example, but we don't know for sure. We're just seeing what can possibly happen. Then we take this and we adjust it as we would with whenever we throw over here, where what we do here is a negation. So we get false and then true. The negation case isn't very interesting. There's not a great deal to it, but it does start looking at our way towards what goes on with truth table and get a better sense of what we do here. We're going to look in the next part at taking some compound statements, specifically with conjunctions and disjunctions.